Hi everybody, I'm John and I got inspired to make a short little video about the conjunction of Jupiter and Saturn. It's kind of cool and people are talking about it. So I hope some of this information is useful and interesting to you, and it's going to be low production value, me and my chalkboard, but I hope that doesn't distract too much. So I have some pictures. Here is a picture right now of what the solar system looks like. Here is the sun in the middle and the Earth's kind of on this side. And here are Jupiter and Saturn. And from our point of view, they are looking like they're basically lined up. And what's kind of interesting is how far apart they are. Saturn is about twice as far away from the sun as Jupiter is. So this lining up is taking place over a very large distance. Instead of saying millions and millions of miles, a convenient measuring system is to use the distance from the Earth to the sun as a measuring stick. And we made up a name for that, and it's called an astronomical unit, or it's abbreviated AU. An astronomical unit is about 93 million miles, or it's about 10,000 times bigger than the Earth's diameter. So anyway, if one astronomical unit is from the sun to the Earth, then Jupiter is about 5 and Saturn is about 10. So they're really far, and they're really far away from each other. You can see from the chart, and by the way, this chart is the only thing to scale of this chart are the orbits. The sizes of the planets and everything, of course, are exaggerated, but the circle orbits are to scale. And another really interesting thing is how fast it is going. And it's going about 22,000 miles per hour. 22,000 miles per hour, which is about 30 times the speed of sound. That's how fast this giant planet is traveling around here, about 30 times the speed of sound. So that's super cool. So if you look with your telescope or binoculars or something tonight, you'll see Jupiter with its moons lined up, and they're kind of in a line, and then you'll see Saturn pretty close. And one interesting thing is that the moons are kind of all lined up in a straight line. They might not be in this orientation, they might be in, one might be over here or whatever, but they're in a straight line. And Saturn's rings are sort of, not exactly, but sort of also in that straight line. And the cloud patterns on Jupiter are also in that line. What's really interesting is basically almost everything in the solar system is on that line, right? If you take that same straight line, the moon's going to be on that same straight line, and it's going to travel on that line. All the other planets are going to be on that line. The Earth, the moon going around the Earth, the planets going around the sun, everything's basically on that same path. There's a few interesting exceptions, but basically everything in the solar system is on that same path. That's why it's possible for these things to line up, because they're at least basically in the same path. They're not just randomly oriented. And the reason all these things are in the same path is because they all formed out of the same spinning mass of gas and dust that formed our solar system, sort of like, like if you see a galaxy that's nice and flat and it's spinning around, everything kind of formed out of that one flat spinning disk. And so it's all kind of oriented in that same spinning direction. But there are some interesting exceptions, like Venus is going backwards and other things. Jupiter has lots and lots of moons, but the four main ones we can see are these four bright ones you can see with the binoculars usually. And the first time those were sort of noticed to be going around Jupiter, that the first time somebody figured out that there were moons and not just random stars, was in about 1610. We think of Galileo made a telescope, pointed it up there, and took really careful notes. He at first thought they were just stars, but he watched over days and days, and over days this one was over here, and then later on this one was over here, and he took careful notes and figured out that there were 4 of them going in the different sized orbits. And here's a picture of some of his notes. And so he described this, and it was the first time anybody had seen anything orbiting something that wasn't the Earth. They thought everything orbited the Earth. We now call these the Galilean satellites. It turns out that there was a German astronomer exactly at the same time who discovered these independently of Galileo, a guy named Simon Marius. I don't know how to pronounce it exactly. And he gave them the names that we have today, and they're named after lovers of the god Zeus. And in increasing distance from Jupiter, they're called Io, Europa, Ganymede, and Callisto. And they go around Jupiter. This is to scale. So this is their distances from Jupiter, and the size of Jupiter are to scale. Not the sizes of the white dots. They're not to scale. And I wrote down here the numbers. It takes Io 2 days to go around, all the way around Jupiter. So that's really fast. So if you look at these from one day to the next with the telescope or binoculars, you'll just in even less than a day, you'll see they're moving all around. So that's one of the reasons that Galileo could tell they were moons, and it's just one of the fun things about looking at them is you can watch them moving around. Europa takes 4 days, Ganymede takes 7 days, and Callisto takes 17 days to go all the way around Jupiter. Saturn also has a bunch of moons. Well, it has the whole rings, which are lots of little teeny micro moons, but it has one big moon called Titan, and a bunch of other little moons that you can't see. Titan's hard to see with binoculars. It's not, because Saturn, right, is so much farther than Jupiter. Its moons are very, very dim. And another cool thing about the distances and looking at them is that they're about the same size. The planets are about the same size. Because Saturn is about twice as far away from us as Jupiter, it looks like about half the size as Jupiter does. And it's a lot dimmer. And so is its satellites. So why is it so rare that we get a conjunction like this? Why is it such a big deal? So if we look at this chart, you can see, okay, here's our vantage point from the Earth at this little radius here, and here's Jupiter and Saturn lined up. And what's going to happen now after today is Jupiter's going to keep cruising along its orbit, and it goes a lot faster than Saturn. It takes 12 years to go around, and Saturn takes 29. So Jupiter, if Jupiter's over here, for example, there's no way we can see them lined up. So Jupiter's going to cruise around for its 12 years. When it gets back to here 12 years later, it'll be in the same place, but Saturn will have moved, about halfway around. So then Jupiter has to take some more years to catch up, and eventually somewhere over here they'll line up again, and there'll be another conjunction, and that takes about 20 years. That happens about every 20 years. But the conjunction we have now is especially rare, because normally when these two are lined up, they don't get so close, and the reason is that the planes of their orbit, so if here's the sun and here's the orbit of Jupiter, the orbit of Saturn is off at an angle like that, and it's still roughly flat. I'm exaggerating the angle, but they're not completely lined up. And so normally when they're in the same place, one's going to be higher than the other, and they won't be so close. This particular one happens at a place where they're both at the same, both in the same plane. So they're not only at the same angle around the circle, but they're both at the same height in their planes, and so they get really, really close together, and that's what's going on. And I think the last time that happened was thousands of years ago. So anyway, I hope that's useful stuff, and go out and enjoy it after sunset, and pick a nice place to watch and be with good people and stay safe.